So very good morning, dear participants, and today we are having very eminent personality with us, Dr. L N Sharma ji. He is professor at Punjab Engineering College, Chandigarh, and his specialization is in GIS technologies. So today, in this scenario, if we want to develop a smart city, so GIS application plays a very important role in that. So we specially called him because of his expertise and in the field. So, sir, welcome you, sir. And now I would like to request Dr. Sanjay Sharma to kindly say a few words. Dr. Sharma.
Okay. So good morning, Dr. Sharma, and good morning to all the participants. Uh, I welcome you all for this program on second day. And today we have with us Dr. L N Sharma, who is a professor in Punjab Engineering College, and his specialization is GIS applications uh, in the in various areas. And like in smart cities or developing smart cities, GIS is going to play a very important role, because everything we want online, everything we want data. So basically, so this part of what are the basically options and how we can use those sorts of things. It is very important. So we can, I think that this topic and with Dr. Sharma's experience, I know that we will be going to have a very useful and interactive session with you. And I'm thankful to Dr. Sharma also, because I think we requested him for a change, and he very readily agreed to our request, so that we can and he accommodated us. Thank you very much for your for sparing your valuable time for this session, and I hope that all the participants will have a very good interaction with you. So thank you very much.
So thank
Hello.
you, Dr. Sanjay Sharma. So now I would like to request Dr. L N Sharma to kindly start his presentation. Dr. L N Sharma, please.
Good morning, Professor Sharma and Professor Goyal. At the outset, I would like to thank you for providing me this opportunity to interact with your participants, which is, I understand, from across the country. So I'll be talking about basically on GIS application, but nonetheless, I will just introduce remote sensing part also, because I feel GIS is a platform which integrates, but then how do you capture data is also important, whether from the ground or remote sensing. So I'll give you glimpses of remote sensing, but basically more on the GIS and current scenario in our country about the smart cities. Okay, so shall I begin now? Okay.
Yes, sir. You may
Yes, sir.
start, please.
Yeah,
You may
You
start.
can share your presentation.
thank you. So is it visible to everybody?
No, sir, it is not visible.
Okay. Uh,
Sir, once you click on present now and then your entire screen, a new window will come up, sir. So in that window also you have to click on the window that is inside. Then you have to click on share.
yeah, I have shared, but it is not working.
Yes, sir. The share button will be grayed out until you click on the window that is inside. It will be showing a Google Meet window inside also, na?
Okay, okay, I got it, got it. Thank you, Professor Goel. Thank you.
Okay, okay, sir.
Uh,
Yes, sir. It is coming up now.
now it has come.
Yes, sir. You can do the
Okay.
full screen now.
Okay, thank you. So,
Sir, just press hide button, sir.
pardon?
Hide button, sir. Hide button. This hide is there, na? One window
Hide.
is coming in the slide. Hide, sir. Hide, sir. Hide button.
It is showing stop sharing. Oh, okay,
No,
okay,
no,
hide,
sir. Hide.
hide,
Yes.
hide. Now it is fine.
Yes, sir. Yes, sir.
Now my text and everything is visible, right?
Yes, sir. Yes, sir. You can start.
Okay. So good morning, participants. The topic given to me is GIS application to the smart cities. But however, I felt that if you know, GIS is an integrated to integrate the data, but then remote sensing also plays an important role in capturing data, whether it is field-based data or remote sensing data. Ultimately, you bring all these data.
Hello, sir, it is not visible now.
Actually, Mr. Rabini Sharma shared the screen in between, so that is why. Sir, I would request. I'll just end the screen and tell me if it is visible now. Is the presentation visible now to everybody?
No, sir.
Sir, L N Sharma, sir, I would request you to kindly please stop sharing once and then share again.
You are
I
no longer.
request all the participants kindly please don't share your screen in between when the expert has started with the session.
Okay, I have to again restart.
Yes, sir, you have to just go to stop present, then you have to present again.
Okay.
Sir, you can click on stop sharing in that is coming at the bottom now.
Right.
Yes, sir. Now you can again go to present now
Yeah.
and do the same procedure, sir.
Right. Is that
Yes,
fine
sir.
now?
Yes, sir. You can click on that hide button on the bottom of the screen
Yeah.
and then you can do
Okay.
the full screen.
Fine, fine.
Thank you so
Now
much, sir.
everything is fine.
Everything is fine, sir.
Okay. Thank you, Professor Goel. So what I'm going to do is I will speak cover through some slides on the GIS, then a couple of slides on the remote sensing, and ultimately more emphasis on the applications part, how you can use GIS, particularly in the smart city scenario, current scenario. What is the current scenario of our country, wherein hundred cities have been identified as a smart cities, and what is their progress? Although the project was started somewhere around 2016, but there are limitations and so on, we'll see. So GIS is nothing but geographical information system. So GIS is a geographical information system wherein you need a software system for input the data. You have to store the data, so you need a very huge storage capacity. You can retrieve data the way you want. You can analyze. You have super fast computers. Through that you can analyze and display this geographic data, the spatial information, onto the system in a different formats, whether it is a chart, whether it is display onto the screen, or whether it is sending onto the printer. Now, a typical example is you input the data into the system, then you analyze them. You need a expert for analyzing. You need a software, and ultimately you display this data in the form of the maps or tables or graphs or pie charts or whatever way you want. It could be graphical, it could be attribute data, it could be tabular, and so on. So this inexpensive map production, display, and easier analysis don't need a professional cartographer, but still need analysis. My point here is, uh, although you don't need highly professional people to operate this geographical information system, but you still need analysis. Analysis is to be carried out by an expert. For example, I understand many of you are from the engineering background, whether it is civil engineering or whether it is electronics or electrical or computer science. You have to analyze the data, whether it is statistical analysis, whether digital image processing, or if you to process the satellite data, you may use digital image processing. So, and a geographic information system is a computer system which captures, stores, and checking and displaying the data of the Earth's surface. Basically, you are compiling all this information about the Earth's surface. GIS can show you many different kinds of data on one map. Now, interesting thing here is, on the map you can show the text. On the text you can click, you can connect it with the map, and both are interlinked. That is the beauty of the GIS, and it enables people to make easily see, analyze, understand what are the different patterns, what are the different relationship between the geography of the area. For example, I want to tell you what is the relationship between soil and agriculture, whether it is a soil is fertile, soil and water availability, soil and soil moisture. So this kind of relations, these patterns, okay, pattern I would say, whether this particular area is having a typical pattern of not supporting vegetation, not supporting crop, and things like that. So GIS software is designed to capture, manage, analyze, and display the forms. GIS allows to view, you can understand, you can question, queries, internet, you can put all your files onto the internet so the large audience can utilize this and visualize the things. So it's a map, globes, reports, charts, and these are the things by which you can display the information. So basically, what are the components of GIS? You need a computer system, you need a scanner. Scanner is scanned to input the maps or digital data into the system. You need devices like printer, plotter, and so on. Similarly, you need to have a software. There are hundreds of software available. I will give a couple of names to you in due course of time. You can note down, and usually I prefer, whenever I deliver the talk, I prefer that if a participant can interact later on with me and develop their own application in the chosen field, whether civil engineering, electrical, electronics, or demography, or medical science, or whatever. Even now medical science is also using the geographical information system. For example, in this COVID also, they want to understand how it is spreading, right? So the spread pattern of the spreading can be analyzed using the GIS. So you need different software. So there are different software: MapInfo, ArcInfo, AutoCAD, and things like that. Then data, how do you capture spatial data? So data, for example, I'll be giving more and more example of Chandigarh since I'm from Chandigarh. Let's say Chandigarh's map is to be digitized. Chandigarh's tabular data, census data, medical data, education data, health data, waste disposal data, have to be, and they are available in the both the formats, in the form of map as well as in the form of tables. So you have to digitize them. You have to put the you have to capture this data into the system, and then there are people who use this GIS for different technical. You need different experts who design the geographical information system for you, and there are methods which are used for the. Now, what are the different functions? Data capture. So how do you capture the data? The input of data into GIS can be achieved through many different methods. For example, aerial photographs. A aircraft is flying on the height and collecting the photographs. That photograph you can scan, and you can scan it directly, put into the system. Then you can scan the map. You can digitize the map. You can use directly GPS data. Now everybody knows about GPS, whether it is handheld GPS or differential GPS. Nowadays it is available in even in watches, wrist watches, and so on. So straight away you can bring this GPS data into the GIS. Now, second is storage. The more bigger application you are looking for example, if I say for entire Chandigarh, I want education, I want waste disposal, I want civil aviation, I want every other detail digitized and put into the system. I need some sort of mainframe system because this cannot be done on the personal computers or laptops. So data storage, since and digital data takes a lot of memory. So earlier it used to be on the floppies, hard disks, CDs, and so on. Now the storage media is also improving, and the memory is also improving. So so your storage capacity also is improving. Data manipulation, once you have added data into the GIS system, you can add, you can edit, you can delete, you can specify, you can modify. Now this is the beauty of GIS, which any other software like Arc, AutoCAD and others do not support this kind of system. Whereas this and your Google Earth also does not support this addition, deletion, and things like that. This GIS only supports this. You can generate queries, you can generate questions, and you analyze them, and then finally you can use the visualization to represent or to present your work into the different formats, either in the form of map or the digital tabular formats. So basically, there are two types of data. When I say let's see, some of you may be from southern part of the country, Tamil Nadu, Kerala, or Gujarat, or whatever district. Your district data has to be put into the let us say from Punjab or Haryana. Your district data has to be put into the GIS. How do you do it? There are two types of data set. One is known as vector, other is raster. Vector is point, line, and polygon data. That is, suppose I have a river. So what I will do, how will I digitize a river or road? I will start a start point and end the river where it is meeting the sea. But I will start putting all the points, and then these points will join and becomes a line, and line joins become the polygon. Suppose there is a circle, I can make it as a polygon also. Then second set of data, for example, raster. Raster is a cell, pixel or picture elements, they popularly known as. So this is how we have to capture these two types of data of the Earth surface into the GIS. Now you see in the this rectangle, there are different points. The middle one is line, for example, drainage. Civil engineers would understand this. Third one is polygon, more closely resembles the real world. In the real world, if you look at the topography of the Mother Earth or your district, you will have river, you have plants, you have crop, you have roads, you have vehicles flying. So how do you represent them? Whether it is a point data, whether it is a line data, or whether it is a polygon. Polygon, you can join points and lines and make encircle it, and within that polygon you can again show the point data, or again you can show the line. So that is the vector format of representing the raster. Areas are broken into pixels. As you can see in the bottom picture, you have rows and columns. So the particular location of a location on the ground can be measured using rows and column. So for example, in bottom side, you have rows 1, 2, 3, 4, 5, 6 rows and 6 column. So vertical is column and horizontal is row. Now you can represent these rows and columns, whether a river is flowing from this, water is there, or grass is there, or forest is there, and ultimately the top form, where you are shown a map, the grid will show you a map something like this digitally. If you expand it, it will look like this. Each cell contains data. If cell does not contain data, it will be filled with the 0. And good at representing dense data, land cover, elevation. You can fill any information in this raster format or pixel format. Now here I am giving example of raster and vector. As you can see, the real world is something like this. You have A, B, C, three attributes on the Earth surface. Now in raster format, how this A will be represented? You have 1, 1, 1, 1, 1, that is A, 2, 2, 2, that is B, and C is 3, 3, 3. So this is how, when you digitize into the system, The raster data model will be filling the individual cells 111A, 222B, and 333C. Now, and you can create the table. As you can see on the right side, so ABC, I have variable 1, 2, 3. You can create a relational database. I don't know, some of you must be from computer science or who understand what is the database. They should know that relational database is a database system and which is used in GIS, and what it does is it stores thousands of tables. Now you have to provide a key in these tables, a common key, and this common key will link these relations between the different tables. So that is why it is known as relational database. Usually for storing the data into the, whether it is a raster system or vector system, they use this relational databases tables. But then here there is a, okay, this is how you can basic properties of geo. So in GIS you must understand geographical information is very important. Geographical information in the sense topographic details of your transportation, your drainage, your medical institutions, your educational hubs. What is their geographical location? Now, when you store this data, well, this data, how they are, what is the characteristics of this data, or what is the property of this data? What is the size of the data? I am interested in knowing the size of the building. So whether it is a small building or a big building, whether it is a small pond or a big pond, what is the distribution of these buildings? They are closely spaced, they are far off. What is the pattern? Do they follow any pattern? These buildings, educational system, my westland, does it follow any pattern? Contiguity. What is continuous to what? And what lies neighborhood? Neighborhood means, for example, close to national highway, is there any medical facility? Close to national highway, is there any school or a college or higher educational institution? What is the shape? In addition to size of the my object, what is the shape of the object? Is it triangular? Is it circular? It is a rectangular, or it is a linear? Is it a line? Is it a rod? Is a, so shape is also important, and then scale is very important in all these topographic features. Scale is very important. What is the orientation? Now, when we talk about the geographical data, you must understand the orientation or the direction with reference to north. With reference to north, what is the direction of my object? Is it south? Is it north? It is west or east? So orientation of data. So these are the basic properties of the geographical features which we will be looking for while digitizing them. We will take care that, okay, while digitizing, then you analyze and come out with the these features. Okay. So raster stores images as rows and columns. I told you is in rows and column, and we call them digital numbers or pixel. You can say pixel or digital number. Usually represent as square grid cells that are uniform in size. You cannot have one cell small and one cell big. You have to uniformly cut the entire scene into the grids. Now data is classified as continuous or thematic. If it is a continuous data, it is continuous. If it is theme, there could be theme, and this data can be in the TIFF, GIF, or this kind of formats it can be there. How do you represent this spatial data in vector format? Now let us understand. This vector format allows to specify spatial locations and assumes that geographical space is continuous, not broken up and into discrete grid squares. So we store features as sets of XY coordinates. Now, as you can see here, there are one yellow feature, there is a green feature, red feature, and there is a river blue line, which is a river. Now, all this data, we have digitized them in the vector system using the vector data type, first through the points, then making the line, and then making the polygons. So this distinction has to be very clear, that vector uses point, line, and polygon data, whereas raster uses the grids or the shapes. Now, again, I'm giving, you see on the top, this is the real world. Real world, you have a hut, you have trees. There are two huts rather. one on the right side of the river, and there is in between river is flowing. Now, how do you represent in the vector and the raster data? So as you can see on the bottom side, left side, RRR is the river. So this is how it will be stored into the pixels, or that is a raster representation. And the vector representation will be, for example, you have hut. Hut will be represented as a point on the right side vector representation. As you can see, hut will be represented as a point. There are 2 points. Then now, if you see very keenly, you will find that the real world shows 3 plants, 3 trees. Now, in the bottom side in vector representation, I have shown them you making a polygon. Why? Why I am saying is because it's a cluster of the trees. So cluster of trees you can represent by saying that okay, it is a polygon. So you can the entire area you can make a circle, encircle, and make it represent that into the vector format as a polygon. So this is how some geographical information system software will look like. You will have a graphical representation, you will have a tabular data, and this GIS links graphical features, entities to tabular data. As I told you, no other system like AutoCAD and others, they have limitation. GIS has this facility. You can show your map, you can show your attribute data, and you can click onto the attribute data, its location will be shown onto the map. If you click onto the location of the map, it's a tabular format. All the information you can parallelly see it here on the screen itself. You need not take a printout. You understand? Okay. For example, in this case, where I am clicking onto the map, and it's information about all information about that map, all attribute data information in the tabular format will be displayed there. Similarly, we can do for the graph also. Now, GIS is a buzzword, is a geography, the study of where features are located on the Earth feature. And you know, Earth is an ellipsoidal body. So geographical coordinates are very important. In GPS, what do you do? In Google, what do you do? You use in Uber or in your Ola taxis when you move, and the driver or your mobile shows that okay, you are moving with reference to the north and all those things, right? Actually, the science behind that, all this information is already stored into the geographical information system, very powerful information system. But then here, these geographical data are stored, but Earth is ellipsoidal. So how do you bring this ellipsoidal or circular data onto a flat bed? The geographical coordinates, latitude, longitude, in this case, for example, can be represented exactly what is your latitude, longitude into a different, using different formats. We call them georeferencing or geocoding. So the process of assigning geographical coordinates to features. So now let's say Chandigarh, where is the Chandigarh? 32-degree latitude, 76-degree longitude, right? Similarly, Tamil Nadu, somewhere south, it will be further latitude, longitude will change. Himachal is latitude, longitude will change. So whatever your object is there on the Earth's surface, you are representing that Earth's surface by means of latitude, longitude, and that latitude, longitude, you are providing information to the system into the GIS, which will be stored into the file, and this is how it will be represented. Now, for representing this ellipsoidal or circular thing, there are different projection systems. So we have to use a projection system. So your Earth object, for example, in Chandigarh, I have this medical college. So then I have provided its latitude, longitude into the file. Now, why I am giving? Because later on, this is called a georeferencing with reference to the Earth. Because there, once I have georeferenced the data, then anybody on the globe can refer that where is that medical college in the Chandigarh. Its latitude, longitude will be known. So now coming to that circular or ellipsoidal data, we have to use map projections to bring this ellipsoidal or circular data into the flat bed or in the form of a map. So there are different projection systems: cylindrical, conical, planar, transverse, Mercator, Robinson, Albatros, and so on. But we use cylindrical, conical mostly for remote sensing data, or sometime TM also. So now coming to capturing the data, that georeferencing part, for example, a surface picture, you have some river, you have some farmland, you have educational hub. How do you capture? So you can scan all the map. For example, I don't know if you civil engineers are sitting, they know what is the topo sheet, or geologists, they know the topo sheet. So you can simply scan all the maps. You know, map you can simply scan and convert into the raster data. You know and understand now raster and vector. Now, once you have rasterized the scanned the new information, then you start individually digitizing individual features selected from the map as points, line, and polygon. So you can start digitizing. For example, there is a national highway passing from your, let's say, Chandigarh. So what I will do from one end to another end, I will digitize that national highways important points and join them through a line, and I will say, okay, it is passing from this point to that point. And then I will georeference it. One thing is I have captured the data using the scanner and digitization. Secondly, I am now georeferencing using that map projection system. I will bring it to the real coordinate system of the Earth. So then I will do the georeferencing, and then you can view the information. Now you see AutoCAD does not provide this kind of facility. Smart interactive functional map. You can edit the map. You can delete the map. You can modify the map. You can modify the attribute table. You can delete more attribute table. This kind of smart interactive functional things are not available in any other. A set of tools are already available. Statistical analysis, your all in they are inbuilt into the a set of tools. Language, it supports all the IMG file, TIFF file, all, and you can convert from TIFF to IMG to TIFF, and so many other things. It is possible using the this set of tools available in the GIS. And then, as I said, it uses the database management system, relational database management system. So it thousands of files, thousands and thousands of maps you can put into the system. You can find out the relationship between these maps and tables, between the table, between the map to map subtraction, map to map multiplication, map to map division is also possible, which is not provided in any other system except the GIS. So most popular GIS, there are, as I said, hundreds of GIS, but this ArcGIS is very popular. So it will look something like this. You have view and edit data. You can edit the data, and there are tables. You can edit tables, and similarly you can edit the map, and then you can analyze the information. You can create the map out of whatever you have put. And then there are n number of statistical tools, and within that image processing tools, image processing to settle tabular data, and tabular data to graphical data. These data tables are, and thousands of data and tables you can store, and maps you can store into the system. Now it's these geographic data are, you can say, mainly into two framework. One is framework data. For example, an estate officer may be interested only in land ownership, or a transportation engineer or highway engineer may be interested in only in transportation, or a water resources person may be interested only in the surface water bodies, or similarly a topographic person may be interested only in elevation data. So when you draw the information of geographical data about a particular this thing, then you call them framework data. But if you are looking for a particular theme, for example, Chief Minister wants to know what are the flood static zones in the district or in the state, or what are my wetlands in my district, or what is the land cover width, what is the land cover width, does it support crop, and a water resources person may be interested in knowing what are the water lines, sewer lines, or agriculture may be interested in knowing the soils. So then we call it as a particular thematic information, addressing a particular theme. Then we call it as a thematic data. So coming to the analytical part, see, for example, it provides proximity analysis. Now you can see there are three squares, point data in the first square, second data, there is a buffer clicked around it. Now I can remove that buffer, making a polygon also, like the third diagram. Now buffer is a deletion of a zone around the feature of the interest. For example, and within a given distance, you can give the r radius. You can say within this distance, within a distance of half a kilometer, 1 kilometer, 2 kilometer radius, 3 kilometer radius, and so on. For a point feature, it is simply a circle with its radius equal to the buffer distance. Now, for example, I am interested in, or the district collector is interested in knowing that there should not be any tobacco vendor sitting close to an educational institution within 100 meters distance, right? So you create a radius around the educational institution, and you don't allow a tobacco vendor to sit there in that area of the educational institution, so that children do not buy the things from there. Now buffer could be around a point, buffer could be around a line, buffer could be around a polygon. So move circle on a specified radius along the line, then it is a your you can create the buffer. Now it may so happen that you may be interested in, you might be hearing, I'm giving you these examples of tobacco and liquor, please don't misunderstand. For example, a national highway is there. So government says that all along the national highway, within the periphery of 100 meter to 200 meter, there should not be any liquor shop, right? And don't give any license to the liquor owner within that national highway range of 200 meters. So this kind of buffers and polygons you can create along the features. For example, here 1,000-meter buffer for the railroad. Wherever there is a rail, there is a rod. Within that rail and rod, you can give your particular application that within 1 square kilometer, 1 kilometer from the railway line or 1 kilometer from the road, national highway, particular activity should not be taking place. So this kind of information you can give. Okay. Now, buffering is also what loads are located near this road. Now, near this road, what are the loads, parcels? 60 meter from the road, what are the different parcels? Is it a farmhouse? Is it a building? Is it airport? What are the things? So you can, that information also, once you have fed into the system all this information, you can bring out this information in this way. Then overlays. You can overlay, that is, overlay that operate in special entity from two or more maps. There are two maps. There are two different maps. And I say, take information about the soil from one map, take information from the other map about the crop, and overlay on which type of soil is supporting which type of crop. This is known as overlapping, where spatial data are overlapped, combined. Intersection is also possible. One of the most fundamental of GIS operation, this overlay is very, very useful. And these overlays could be vector. You remember vector, point, line, and polygon. So point to point between two maps, whether two points are matching, whether two lines are matching, whether two polygons are overlaid, and raster overlays cell to cell, rows and column of map 1, rows and column of map 2. You superimpose one over the other, overlay over this, and then you can find out the relationship between the different objects. Then there is a Boolean operations. If A is union to B, or A is intersecting the B, what are the intersection areas, graphical areas in both, in the form of map as well as in the form of tabular data you can generate using the Boolean operations. So these are some of the, you can create something like this 3D Okay, let's talk about the now applications. GIS has application in almost every sector, whether it is government, business, utility communication, natural resources, additional industries. In government, you see, state level, local level. I do not know who is my audience, but I know this, that if you are from different state and districts, engineers or academic people from academia, you know that now each state government has decided to put all this data into the digital format, that is in GIS. I know about the Haryana, Punjab and Himachal, all land records, whether it is Khasra, Khata, this your Patta, all your maps, everything is digitized and put into the GIS. All your land disputes, whether into the court or now in the different courts, whether it's district court or the high court or the Supreme Court, all these court people are also, judiciary is also using the GIS data for settling the dispute about the land record, because computer, once you digitize, it does not lie, right? So state level, this land administration, public works, wasteland disposal, urban and regional planning. I can share about the Chandigarh. We have a urban and regional planning department. They are also using extensively GIS. We have a smart, Chandigarh is selected as smart city. Smart city, I will show you some of the slides where they are using GIS. Business people, they are using in real estate, banking, marketing. They are using the supply chain. Then utilities, whether it is electric line, gas, pipeline, they are also using GIS. I will give you some of the example. Natural resources, agriculture, environment, extensively this is used in environment, forestry, ocean, water resources. Climate people are using now GIS. Then defense, of course, educational institution, health. I can share with you, we have a postgraduate institute of medical science, which is equivalent to your AIMS in Delhi. Very huge, popular, most important, one of the important medical facility center in Chandigarh. They are also using GIS now. They are training their doctors onto the GIS, particularly as I mentioned earlier. For example, if they want to understand what is the how this COVID is spreading, from one district to another district to the state level, they can show very nicely, analyze this data and show it into the GIS. Now quickly, I told you GIS integrates the data, but from where the data will come? The data will come from the ground. The data will come in the form of maps. Data will come form of the tables. Now there is a very important technique which is in the last 3 decades, which has captured the eyes of the scientists and very popular now among the scientists and engineers. That is remote sensing. You can directly catch the information about the earth features using the remote sensing data through the satellites or through the aerial photographs, and bring directly that information into the GIS. So remote sensing data, GIS, the ground information data, you integrate them into GIS, and then useful interpretation can be brought out, and your results will be more accurate and more precise. So this is how remote sensing, I will not go into much detail. Basically, there are satellites flying, a number of satellites, and usually I tell my students that whatever kind of congestion you are seeing on the roads now, after a decade, you may have all these satellites flying in the space, and you will have congestion. There are also now even satellites, they have come down, or after satellites coming down, now they have drones. So we have come to the drone. Everybody, you can hire a drone for your own city, for your own marriage party, and you can take the pictures and bring them into digital format and GIS. So there is a sun's energy falling onto the Earth's surface feature. This energy is reflected and recorded by the satellite. There are 2 types of satellites. One is geostationary satellite, which is a weather satellite, and other one is polar orbiting satellite, from pole to pole, north pole to south pole, and they are flying 700 to 900 kilometers above the surface feature. Isn't it interesting science? 700 kilometers above from the Earth's surface, it is observing as minute thing as a your half a meter or a 1/4 meter of any object. They can detect, and they can precisely locate its location. So this is very, and India is one of the leading country in using the remote sensing data for science and technology. There are satellite, there is atmosphere satellite which is moving around the earth, and it is collecting information. Like here there is a rectangle shown here, so we call this as a scene. So there is a one scene it captures, and it converts this digital data. This digital data is provided to the ground station. Ground station, it will send to the scientists and engineers who will analyze this data. So there is two types of remote sensing. One is active remote sensing, the other is a passive remote sensing. Passive is when sun's light is used. This is passive remote sensing. So sunlight falls onto the earth feature, and reflected energy from the object is recorded by the satellite. Active remote sensing is a synthetic aperture radar, or we call it is a SAR, which has a all-weather capability. Sunlight or clouds does not matter here. It has penetration during the clouds also. Okay, so there are different sensors which can sense these Earth features. There are Landsat, US, Aster, QuickBird. Our Indian satellite is IRS, LIS-3, and different sensors which actually uh, sensor is a device which is mounted onto the spacecraft or onto the satellite, so which records. Sensor is basically camera. So different cameras, hundreds of cameras are mounted there. They sense the information about the earth feature, convert this into the analytical to digital data, and then the digital data is processed into the digital format. So this is once again active and passive, and as I said, I will not go much into the detail of remote sensing because we are talking about GIS. So, but then resolution is very important. Spatial resolution. So from satellite, which is 700 kilometer away from the Earth's surface, now, as I said, we have reached to a stage. Earlier 80-meter object would appear as a 1 pixel onto the digital data. Now we have the advancement of the technology has brought this resolution even 1/10 of a meter, that is 10 centimeters, can be picked up by the satellite, 700 kilometers. So resolution has improved. So there is a electromagnet. There are different bands. Different bands means different cameras. So, for example, in this case, I have shown you there are four bands: band 1, 2, 3, 4. So, four cameras are looking at the same Earth object in different wavelength region. Wavelength region means electromagnetic spectrum. So, same object is viewed by four cameras in four different wavelength region, and this can be merged. So you know this, and visible portion is the portion through which human eye is sensitive to the visible portion. For other infrared and microwave, we use different sensors. So this is again shown which portion is good for the water, which portion is good for the infrastructure, soil moisture, and so on. There are different types of these regions, which is infrared radiation, and which area is good for thermal infrared, or those details I will not go. Different bands. Now these bands which operate in 0.5 to 0.6, band 4, 5, 6. Now we have come to a stage wherein 200 bands are mounted onto the satellite, and that is known as hyperspectral remote sensing. So initially they started Landsat by US, which had 4 band data. Now this is 7 band data thematic. Now they have 200 bands data. So more number of sensors you put onto the satellite, more memory you need, and these are the things. Okay, the satellite is 700 kilometer, now it is coming down, and it covers the entire globe in 100 and 5 minutes, and 16 days it will come back to the same position and things like that. And these are the different satellites. I just listed few. There are hundreds, thousands of satellites now operating, because every country has its space program. At least India's 100 satellites are already. You might have heard 100 satellites was launched last time. So hundreds of satellites are launched by India's, US. So you can imagine. Now this is a resolution that is 8 meter. The better is the resolution, the better will be your display of the features. You can demarcate features, that is 23-meter resolution, 300-meter resolution, 188-meter resolution, ultimately 1 meter resolution. Which satellite is good for what kind of studies? This is how you capture the data about the field, irrigation, land use, land care, and these are the satellites which can directly river, flood, inundation, snow, and etc. You can capture this information using. This is a science explained. There is an atmosphere in between. There is a sun. Energy is absorbed in the atmosphere. Energy is falling onto the earth object. Some energy is absorbed. This reflected energy is only. So this is the incident energy, energy absorbed, reflected energy, and this is a typical example of three features. That is your water, vegetation, and dry soil. So there are reflectance of this dry soil will be more, vegetation will be more, water will absorb the energy. So there is a reflectance is less. Therefore, we use infrared radiations for demarcating the water. This is the flood map of the Punjab. This is Brahmaputra. This is crop pattern. You know, the crop, when you sow the crop, the signature will be green. As the crop grows, the signature recorded by the spacecraft or satellite will become reddish or yellowish. So this is shown from Punjab, Himachal Pradesh, Uttarakhand, and Northeast. Again, this is Kharif and Rabi. You can, after doing all this, preparing this map using the satellite data, now these maps are prepared in GIS. You can integrate them. You can directly bring the satellite image into the GIS, and from GIS you can prepare these maps. You can prepare different maps data, Kharif, Rabi. You can map to map subtraction is possible in GIS. Map to map multiplication of the features is possible in GIS, which is not possible. Now this is just to show you. Pre-monsoon, pre-cyclone, there was a jetty. If you see in the jetty was washed away, you can use satellite data. Land use, land cover. This is one of the important study where they use land use. What is the land cover with? What is the area? How much area is under what crop? What is the urban area and things like that. Mind you, you are capturing the data through the remote sensing, but ultimately you are this tabular format you are creating through the GIS. This chart is created not by the satellite data. This chart is created by the GIS. So, for example, your all pie chart or this histograms, etc. So basically, you that satellite data you brought into the GIS, you process them in GIS, and then you have created a histogram, something like this, using the GIS. And then you can calculate the area, you can calculate the distances. Again, once again, change detection. For example, again, I will give the example of Chandigarh. In 1965, when Chandigarh was formed somewhere around, then it had only 40 sectors. Today it has 40 sectors and 17 villages added to this. So it is expanding, right? So what are the changes taking place from 1954 to 75 to 93? This is not a Chandigarh, this is something else. This is just to show you the crops. What are the changes taking place? But example is Chandigarh. Now, spatial analysis, you can use GIS, you can land use, land cover. What was the land covered with in 1990, 54, 75? What are the things added? What are the things deleted? Things. Once again, I can share an example with you. In Chandigarh, we had a colony close to Punjab University, and that colony was spread into, let us say, 2 square kilometer area in till 2000. Now this colony was shifted out of the Chandigarh in the periphery of the Chandigarh. Now there is some new features have come therein. So if you have data of satellite data of 2000 and now data, you can compare and you can find out the changes taking place using the spatial analytical tools provided in the GIS. So these are the satellite. Now this is a satellite picture of 0.5 resolution. I told you resolution, finer the resolution, more clarity will be on the features, right? So this is, for example, digital globe. There is a one satellite which has 0.5 meter. This is Iconus data. Once again, you can see the Dubai. You can count even the trees, plants, park, vehicles, and things like that because the resolution is very, very high. Okay, these are some of the image processing softwares. Uh, as far as GIS is concerned, you can note down if you are having pen, pencil, or there is a ITC, International Training Center, Netherlands, which gives you a free of cost GIS, which is known as ILWIS, Integrated Land Water Information System, ITC Netherlands. You can go to the ITC site. It used to be earlier $100. It is a very user-friendly small GIS. You can go to that site, download this GIS and start playing with it, and then you can develop your own application of GIS. And of course, then MapInfo, ArcGIS, ArcInfo, ArcGIS. There are hundreds of GIS softwares available. You can, depending upon your application, you can buy. Okay, now coming to the smart city part. Now, smart cities that provide core infrastructure and give you decent quality life to its citizens. Smart solutions, infrastructure should be smart, and these are the smart cities identified by the government of India. You know, in 2015 or 16, a prime minister has declared 100 smart cities. So these are the locations of the smart cities given here. So smart city is a technically savvy city, addresses issues of unplanned urbanization, knowledge and innovation. 20 into 4/7 water, for example, 20 into 4/7 water supply should be there in the Chandigarh and so on. Electricity should be there on 24 into 7 and so on. And it should be ICT based. It should be interactive and things like that. This is the definition given by NESCO. NESCO. A smart city effectively delivers public services to citizen and business wherever they are located in an integrated. The important thing is integrated, and GIS does the integration of the resources efficient way while enabling improving quality of life, ensuring safety, reducing impact of environment, growing the local. So basically, you integrate all these things for a better life, and so that you can call you it's a smart city. You are living in a so smart cities should have a superior offering of technical, smart municipal supervision, smart transportation, smart environment, smart tourism, and things like that. This is again definition of and since this year's short-term course is about the sustainable development, ultimately whatever you are creating, it should be sustainable. You should live for the generations to come. You should not exploit all the resources in such a way that it does not sustain for a longer period while creating the new infrastructure. So it has to be sustainable. The vision of Ministry of Urban Development, it was a urban development which started, and they are promoting the cities as the engine of the economic development. Earlier, you know, it is industrialized development, industrialization took place along which the development took place. Now they are saying that cities should act as a engine for the economic development. So these are some of the definitions of smart city. You can read it from the books as well as from the other medias. I will skip them. Now, this is that Prime Minister Narendra Modi on 25th June 2015 announced that these 99 cities or 100 cities, they will give financial aid, and by 22 onwards, that is after 2 years, they too should start functioning, and they will create a special purpose vehicle headed by a CEO. So smart city, for example, in Chandigarh, there is a separate department which is known as smart city department. I'll show you. It is headed by an engineer who is the chief executive officer of this mission, and 1,000 crore rupees funding for all this. 500 crore will be provided by the state itself, and 500 the central government will provide. And this 100 smart city mission was given a total of 98,000 crore approved by the government. Now you see, we know that fast urbanization is taking place. In 1951, you see 6.24, and these are the data from the Ministry of Urban Planning and Development. Now you see rapid pace of urbanization taking place in India. 6.24 to 37.1. So completely we are migrating toward urbanization. What was the population? Again, these are the figures you can read, and you can go through. But my point is, for example, let's say Chandigarh. Chandigarh was designed for 40 sectors for a population of 5 lakh. Today, Chandigarh's population is 12 lakh. You can imagine how much pressure it must be putting on the people, on the resources, on the land, on the water. When 25 years back, when I came to this city, the water level was X. Today, groundwater level has reached to X upon 10 times. So that means you are over exploiting the resources, right? Land, there is no horizontal land available now. They are going vertically. So, and your population is growing. In last so many years, in last 30 years, from 1961 to, you see how much population has grown. Now this growth has put a lot of pressure onto the, so therefore you need a smart city, you need a planned city wherein the smart city becomes the engine for your development. So you can see these are the smart and urban areas, metro cities and things like that given here. I will not go into the, you can read from the figures given here. Now just see this, your urban India. Look at the Mumbai. It must be now 2 crore. I have given here 18.4 million, but it must be 2 crore. Delhi also 2 crore. Chennai. Look at this. Your population, metropolitan cities, urbanization is growing. And these are the 2011 data. Now, if you talk about 2021, you can imagine what will be the scenario. So there are challenges in the urban India. No city has now you see here. No city has fully developed 24 into 7 water supply. Only 74% of households are served with pipeline water. You are lucky if you are living in a city. Go to the villages. They don't get water from the tap. They have to go they have to go tens of kilometers, sometimes in the desertic terrain to fetch the water. Only 65% of 3 class 1 cities have a formal city bus service. That is 2012 I am talking about. Only 30% cities have sewage treatment plant. All cities do not have sewage plants. 32.7 urban population has access to the Piper sewage system. 12.6 urban population still they openly defect. Now Prime Minister is insisting upon that, and many cities are now declared that they are defecting free. Only 72% of the solid waste is collected, and only 30% is segregated. What is happening rest to the solid waste? If you travel to the Delhi, you can see left hand side. There is a huge mountain of the solid waste created. 24% urban population lives in the slums. Even in Chandigarh, well, they are calling it a smart city. I told you there are 2-3 colonies which are spread into, and you can imagine they are living in 2 square kilometer area. 1 lakh people living in 2 square kilometer area. How much pressure they are putting onto the land, water resources, electricity, and so on. You can imagine. So therefore, you need a plan, and plan city, and plan means a smart city. So this is where the concept of the smart city came into. So GIS based. Now, what is the role of GIS? GIS can give you total energy. For example, in Chandigarh, we have calculated what is the total energy required. This energy produced through the solar energy, how much energy is available. All rooftops are kept with the solar plants in the all the institutes. How much is the water demand? How much is water produced? For example, let's say it is producing 350 metric ton of solid waste every day. How many vehicles are traveling in a day? Lakhs of vehicles, because from Mohali and Chandurgula, Mohali and Panchkula, every day lakhs of vehicles are coming. So these are the some of the things. Now, for a smart city, earlier your development was on the industrialization, but not today is a growth. Economic growth is on the basis of the smart city. And what is a smart? It should be standardized monitoring, accounting, rethinking, transportation. These all your SCAM they did a study that energy, water, waste policy, physical infrastructure, social data, everything should be on a one place, and one place. It could be in the place of a district collector, or it could be with the CEO of the smart city, where all this information will be digitally available. Now you see water resources management distribution. Now, for example, we have water distribution system in Chandigarh, which is going to be GIS based. It is they are already digitized, and they will use the, and some of the cities in our country, I will give you example. They are using the GIS for distribution of water and food packets and things like that. So smart urban planning, you need green building, smart utilities. Sustainability will be, so how do you achieve sustainability? So you should have information first of all about all the resources, what is the linkage, what is the pattern, smart transportation. Now they are trying to use the smart transportation using a web or a smartphone based application, where in your mobile itself you will have information, number of vehicles playing, which from which station to which station, buses, trains, and things like that. Security is important, healthy environment, integrate, and this can be all integrated using the in GIS. Why do you need? So there is a need for a technology which provides a platform, and GIS provides a common platform. And in all these places, the centralized information could be GIS. So in a GIS, which is kept in for the smart cities, the GIS is kept in a building where the CO is there, and all digitized data is available to you. And this can be helpful to the decision maker, to the district administrators, to the district collectors, and so on. GIS is very efficient, green, it plays a critical role. And in this smart urban planning, smart utilities, I have already told you. So GIS is a central place, central platform on which smart policy making, smart planning, smart end-to-end solutions, smart services, management. Okay, let me tell you, I know some of the other cities also it is there, but in Chandigarh, in almost in 3 to 4 cluster of sectors, we have these Sampark centers. Sampark centers are using GIS. Water, electricity bill you can deposit there on Saturday, Sunday, on the evening after hours, office hours, and things like that. You can get the stamp paper duty, this notary papers. So they have listed some 40 facilities. You can go to the Sampark center, and all these utilities are available. And basically they are created for the citizens, because citizens during office hours they cannot go, so after office hours they can go, or they can go on Saturday, Sunday. And now this same facility is available onto your mobile, so you can create a login, you can deposit your electricity bill and water bill. So see, for example, Sweden, San Francisco, and others, they are using it for solid waste management. And this is the flow chart which is given by for a smart city domain by the NASCOM, that how integration should be there, application, spatial data, communication, and things like that in a manner. So they have divided into three categories. Mega city, population is above 5 million, that is 50 lakh. Mid-sized city, that is population between 1 to 5 million, that is less than 50 lakh. And population 1 million, that is 10 lakh. So you have Patna, for example, Patna, Srinagar, the Chandigarh, that is a small city. Mid-sized city is, for example, Jaipur, Lucknow, and so on. And the mega cities, Mumbai, and etc. These are the softwares I already told you, ISRI, Arkinfo, there are a number of softwares. Now, in some of the examples I will share, for example, smart city concept in India, Lavasa in Maharashtra, I don't know, somebody from Maharashtra is sitting. There is a smart city created in Lavasa where they are using GIS. Gift city, you must have heard Prime Minister is a Prime Minister brainchild, where the Gift city in Gujarat is developed, where all the lines you will be underground, all your sewage line, electrical line, everything will be underground. And Greater Hyderabad, they are using Surat, they are using water quality, they are monitoring using GIS. Coimbatore, they are using GIS. Bangalore, they are using GIS for the property. Jamshedpur, they are using 24/7 window call for customer database. Kanpur, GIS linked property, all land use, land cover data. And they have digitized all these data. There is this national urban information system under the Ministry of Urban Planning. Now you see, they have digitized all these data, 150 towns, 150 towns, 95 towns for at 1:10,000. And as I was telling you, judiciary is going to use. Judiciary is going to use all this, or using this data for settling the disputes of the land. So a stage has come in wherein more and more fine data will be stored. Now this is about that Lavasya. They are using GIS. There you can see the different water body, buildings, and structures like that. Now this is Chandigarh Smart City. There is a site. You can go to this site here. And as I was telling you, they have listed latest projects, public services. What are the services they are providing to the public? Cyber cycle. For example, they have started recently a cycle GIS-based cycle system, wherein you will have on mobile different locations in the Chandigarh. Cycles will be there. You can pay through the Paytm. You can pay the charges of a cycle, how much time you are using the cycle, etc. And then waste disposal ground, etc. So they have started it. Now you see, I told you Sampark centers are there. Water, electricity bill, Sampark, Aadhaar, various forms are available. Different certificates you can, death certificate, child certificate, and all these things are available in now. Bicycle sharing project started in Chandigarh, but this is it is just going to start. Smart parking. smart parking lot, you must be there is a huge amount of revenue generated by these parking lots in Chandigarh, crores of rupees. At least I am sure it is in hundreds of crore rupees they are generating annually while providing the this contract to the people who can provide the smart city location. This is about Dehradun's small area. There, for example, on right side you can see they have created a GIS-based system wherein they, for Dehradun, 35 square kilometer area, 1.3 square kilometer is approximately residential area. Green belt is this much. You can calculate the information. These are the different projects and the features of the Dehradun they have listed here. Then they, again I showed you that this side on left side, this is a smart area required for water, ATM, smart water. There will be water. You can take half liter water from there, buy the water by paying the payment. There is a toilets, things like that. And this is a smart city concept wherein everything will be ultimately available to you on the mobile vans, mobile thing, and all the smart city in the centrally. The lines will be underground. For the example, that gift city of this is a Mangalore smart city. So for creating a smart city, for example, in Chandigarh or this 100 smart city, they have invited applications from the citizens. So then citizens said, okay, what are the things required? Citizen gave water supply, solid waste, and things like that. This is a chart of that. The water supply, wastewater, citizens charter, solid waste management, revenue management, municipal services, all your, for example, registration of the land record, registration of vehicles, and licensing authority, Aadhaar card, and so on. So, and ultimately, as you can see in the center of environment, economy, and social, all three important components, but sustainable development. You must leave something for your grandchildren. Otherwise, the way we are exploiting the resources, I don't think that we are leaving anything for our grandchildren. Maybe they will discover something new, that is a different story. But the way we are exploiting our current resources, natural resources, is a very pathetic condition. So smart city will be something like this. You have Singapore. I don't know whether you have heard or not. Singapore now, Singapore airport is manless. There is no man which is available, manpower available to help you. Everything is digitized. Everything is on the mobile based, things like that. There is a Madsar city, Abu, Los Angeles, and you have a gift city, Chandigarh. This India will look something like this. So my conclusion is, GIS is enabling technology forms the core of the design, development, and execution and management of smart cities. So all these smart cities, which the 100 smart cities, GIS is a core of design. They will be designing whatever technology, GIS or remote sensing or technology they are using. They will be designing in that design, in the development, and in execution, and then management of resources. And there's a interrelationship between all these features and objects. For the smart cities, they will use GIS, whether greenfield or brownfield. GIS can be platform for various departments: education, health, irrigation, mining, services, municipal corporation, exchange information, interact with the citizen. As I told you, see, they have invited applications from the citizen. Okay, you tell us, how do you want your city's waste to be disposed of? How do you want your water resource? How do you want your electricity? So all this can be done using the GIS. So modern technologies, including a variety of remotely sensed data, high-speed networks, provides the real-time data to the GIS for better management of smart cities. So buzzword is, these all 100, not only these 100 smart cities. In educational academia, they use scientific community, engineers, and the smart cities. Of course, since this course is about the smart cities and sustainable development, GIS has a tremendous application in smart cities, or direct application in smart cities and the sustainable development of a city or a nation. GIS plays a very important role. Thank you.
So thank you so much, Dr. Sharma. And now I would like to request participants, if they are having any query, so they can unmute yourself and they can ask. So all of you are kindly requested to unmute yourself and you can ask your queries. Anybody? Anyone from the participant? If you are having any query, you can ask.
Any question from the participant?
Do you have any query? Kindly unmute yourself. Kindly unmute yourself. I think one or two. Yes. Do you have any query? Anybody?
हेलो
Yeah.
Yes, sir.
चलिए जो पीपीटी है इसकी पीडीएफ अवेलेबल हो जाएगी ग्रुप में
बिल्कुल 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 we'll provide all the PDF and lecture,
ठीक है जी
है ना? तो that will be available with you. But
जी
if you are
सर
having any query, you can ask.
ओके सर नो सर थैंक
Anybody from Tamil Nadu? Because many of the persons, they are from rural development and Panchayati Raj, so this GIS application is very important there. So if they are having any query, so they can ask. So I don't feel so there is any query from the participants. So I would like to thank.
I think we can, because this is.
Ji sir.
Okay, I was just trying to interact with the participants that okay, because your interaction with our experts is important because it is a two-way sort of a thing, more of a discussions. Your experience you can also share and application of this GIS in your say routine today activities, how it can be implemented. So from that point of view, I think if you can interact, I think mostly I would like that okay, you should interact with our experts.
Yeah, Professor Sharma, you said very rightly. I would love to interact if anybody has developed any application so far or facing any difficulty.
So Mr. Lakshmanan, can I invite you? Yeah. Anything you want to apply in your field and you are having any problem, so you can discuss with the expert.
Okay, sir.
If you have any problem, my email is given with the Professor Goel and it is given on the PPT also. I would love to interact. Are you using GIS?
Yes, sir. Yes, sir. In MG Energies, we are using GIS, sir.
Which GIS you are using? ArcInfo, ArcGIS?
To update the location of work site.
Location of?
In MG Energies site. Location of work site.
Ore site?
Yes, sir.
Ores, that is mining.
No, sir. No, sir. Work. That means construction site.
That's very good. That's very good. So you must be digitizing the data. You must be using some software.
Yes, sir. That is geotagging software which was in MG Energy site, sir.
Okay. Geotechnical.
We are downloading in mobile.
So Lakshman, what you can do that geotechnical data which you have created, you can import that data into the ArcGIS or any GIS. I gave you an example. ITC Netherlands, International Training Center Netherlands, has a small GIS which is known as ILWIS, ILWIS. You can freely download that GIS into the system, and the geotechnical data you can bring into the GIS, and then process it. I am sure GIS will give you much better information, much better analytical tools there.
Okay, sir. Okay, sir. Any doubt, we will contact further through your email ID, sir.
Yeah, sure, definitely. I would love that.
Okay.
So anybody else? From Punjab Police Housing Corporation, I think GIS application is widely used in Punjab Police Housing Corporation. So if anybody is having any query, so you can ask.
Yeah, in Punjab they are using. In fact, they are using. Urban Planning Department is using in Mohali.
So I think participants are having no queries. So Dr. Sharma, I would like to thank you for sparing your valuable time and interacting with our participants on GIS application. I'm sure some of the participants, they will definitely interact with you through email. So I will provide
Yes.
your mail to all the
Yes.
participants.
Yes.
So thank you so much. Now I would like to request Dr. Sanjay Sharma to kindly say a few words.
Thank you very much, and thank you, Dr. Sharma, for sharing your experience on application of GIS application in the smart cities. And as a, I think the various aspects of how GIS can be used in making our city smart is has been explained in your presentation, and I hope that participants will take advantage of this presentation. And even any inquiries afterwards, I think you are welcome. I will say that okay, if there are certain projects, certain consultancy, if work is there, so I think we can approach our experts also for that purpose
Sure,
later on
sure.
also. And you can that is the one purpose of interaction with you people, that whenever you require any sort of, you basically you aware of the say expert resources, that from where you can get the expert advice. So in that way, basically, I think in the long run also you can utilize the basically availability of our experts who are delivering the various their sessions in this program. So thank you very much, Dr. Sharma, and hope we will be having more interaction with you. Thanks.
Thank you, Professor Sharma, and thank you, Professor Goel, and thank you for providing me an interaction with the participants. Once again, thank you very much.
So thank you so much, sir. And dear participants, now we are having next session at 2 o'clock on IoT application for development of smart city.